Students, today's lesson is on using the Pythagorean theorem. So we already know how to use the Pythagorean theorem to solve for one of the legs in a right triangle or the hypotenuse of the right triangle. Now we're going to be using the Pythagorean theorem for a few other applications. So to start with, we're going to look at the converse of the Pythagorean theorem. So if the equation a squared plus b squared plus c squared is true for the side lengths of a triangle, then the triangle is a right triangle. So when we used the Pythagorean theorem before, we said given a right triangle, we know that a squared plus b squared equals c squared. Now we're saying if it's true that a squared plus b squared equals c squared, we can prove that we're looking at a right triangle. So let's look at some triangles and we'll prove whether or not they are right triangles. So we'll start with this green one here. So we know that the two shorter sides are potentially the legs and the longest side is potentially the hypotenuse if this is in fact a right triangle. So we'll start with 9 squared plus 40 squared equals 41 squared. And I'm going to put a little question mark up here because we don't know if these are equal yet until we simplify. So 9 squared is 81, 40 squared would be 1,600, and we want to know if that's equal to 41 squared, which is 1,681. And yes, we have 1,681 is equal to 1,681, so this is a right triangle. For this next example, we have the two shorter legs are potentially the two shorter sides are potentially the legs of the right triangle, and the longest side is potentially the hypotenuse. So let's go ahead and do 18 squared plus 12 squared, and we'll see if that's equal to 24 squared. So 18 squared is 324, 12 squared is 144. We want to know if that's equal to 567. So when we add those up, we get 468. That is not equal to 567. So no, this red one is not a right triangle. All right, next, we'll look at the distance formula. So this looks complicated, but it's really just doing the Pythagorean theorem a little bit in reverse. So the distance between any 2 points, we have these 2 points, is given by the formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. So we can see that the distance between any 2 points, we're really just looking at how we're setting up this as a right triangle. And then we'll use this distance formula to find the length of the hypotenuse. So here we want to find the distance between 1, 5 and -4, -2. So let's go ahead and plot them on our graph, 1, 5 and -4, -2. So we want to find this distance. And to do that, we'll be looking at this as a right triangle. We'll be finding the lengths of each of these sides and squaring them, and then taking the square root to find the hypotenuse. So we're working a little bit backwards from the Pythagorean theorem. So let's start with distance equals the square root. Now we're going to subtract our two x values because we had x2 minus x1. So x2 we'll use as -4 and x1 is 1. So the distance between those two x values is 5. But we'll write it down as -4 minus 1 squared plus, now we're going to subtract our two y values. So we'll have -2 minus 5 squared. Then we'll simplify that to -5 squared plus -7 squared. Now, doesn't matter which point you use as x1 and which point you use as x2, because we're really just finding the distance between these. If we did 1 minus -4 instead of -4 minus 1, we would have ended up with +5. but since we're squaring this anyway, it's not going to make any difference. Either way, we'll get 5 squared or negative 5 squared are both 25. So we'll say that's the square root of 25 plus 49. And that's the square root of 74. And then we'll use our calculator to get an approximation, and that's about 8.6 units. So here we have this right triangle with a distance of 5, 7, and this is about 8.6, which seems pretty reasonable as we're looking at the picture. Now, our last example, we're designing a football play in which a player runs down the field, makes a 90-degree turn right here. They start here, they go to make the 90-degree turn, and then runs to the corner of the end zone. Your friend runs the play as shown, but we want to figure out, did your friend really make a 90-degree turn? Is this really a right triangle? So we're going to apply what we learned both in example 1 and example 2 here. We need to use the distance formula to find the lengths of each of these sides, the 2 legs and the hypotenuse, and then we'll use the Pythagorean theorem to determine if it really was a right triangle. So let's start with finding the distance for D1. So D1 equals the square root. We're going to subtract our x values. So we're looking at 60 and 30. So 60 minus 30 squared plus our y values are 50 and 20. So 50 minus 20 squared. We'll simplify that to 30 squared plus 30 squared, which is the square root of 900 plus 900. And I'm just going to keep that as the square root of 1800. We'll just leave it as a square for now instead of giving a decimal approximation. And you'll see why in a sec. So that's D1. So now we're going to find D2. So we're looking at these 2 points, 30, 20, and 80, negative 30. So D2, that distance, is the square root of the distance between the x values, 80 minus 30 squared, plus the difference between the y values, negative 30 minus 20 squared. So that distance is the square root of 50 squared plus 50 squared. Okay, that's fine. So that equals the square root of 2,500 plus 2,500, which is the square root of 5,000. So that is my D2. Now let's find D3. Running out of room a little bit here. I'll do it right here. So D3 is the square root. Here we're looking at the difference between the x values, 80 and 60. 80 minus 60 squared. And then negative 30 minus 50 squared. So that's equal to the square root of 20 squared plus negative 30 minus 50 is 80 squared. That's the square root of 400 plus 6,400. So D3 is the square root of 6,800. Okay, so now I have my 3 distances. I have D1, D2, and D3. It looks as if D3 is the longest, and looking at my distances, it is the longest. So now we just need to see, does the Pythagorean theorem hold true? Now, I'm going to erase just a little bit here so that I've got some room to show this. It was 5,000. Okay. So I'm going to do a squared, I'm going to use D1. So the square root of 1,800 squared plus D2 was the square root of 5,000. So that's the square root of 5,000 squared. And I want to see if that's equal to the square root of 6,800 squared. Square root of 1,800 squared is 1,800. Square root of 5,000 squared is 5,000. And I want to see if that's equal to 6,800. If I simplify this, I have 6,800 equals 6,800. And yes, that in fact is true. So we can show by finding the lengths of each side using the distance formula and then using the Pythagorean theorem, we showed that this was in fact a 90-degree angle. All right, that's it. Go ahead and try a few on your own. I'll see you soon.